what is the state of the water on this line?
Saturated vapor.
And on this line?
Saturated liquid.
Very good.
State.
So, and in between it is liquid plus vapor.
Water vapor mixture. Yes.
Vapor
So this part is known to us. Now we are extending this diagram in the solid phase. Okay. So if I extend this, so I will get a diagram like this. One line. This is the beginning of melting. This is the melting process, and this is the end of melting. Then there is sensible heating. Then it will reach to boiling point. The boiling will start and the boiling will end. Then you will find superheated vapor. So if I draw one line, suppose this is one line. So this is what is constant at this line? Which variable is constant?
Pressure.
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 So
Pressure.
just consider that this is 1 atm pressure and you have one piece of iron. So at initially that piece of iron is at environment temperature and it is at stable condition and you can touch at this point. So at this point the temperature is environment temperature 30 degree. Now if we start to heat this iron, the temperature will increase and after some time it will become extremely hot. Okay, hot around 500, 600, 700, 800. Slowly the temperature will rise. The temperature is increasing, but the curve is still horizontal because it is a PV diagram. My pressure is constant. The temperature is moving in the upward direction, but my pressure is constant and slowly it is approaching its melting point. So this point is the melting point. At this point, temperature is around 1500 degree Celsius. So at 1500 degrees Celsius, the melting will start. So now slowly what will happen? Some part will remain solid and the rest of the part, remaining part, slowly melting. But during that process, the temperature will remain constant. Okay. So between these two lines, this line and this line, this zone is basically the solid plus fluid because already some part of the solid iron is there and some part already started to melt. After just like a ice melting process. So you have a glass of water, the remaining part is at water and there are some ice cubes, but the whole thing at 0 degrees Celsius. Gradually after some time the complete ice will get melt. So I am not giving the ice example, I am giving a solid iron example. So this solid iron example, if you start to heat it, initially it will reach to its boiling, it will reach to its melting point. After the melting will start, so everything will convert it into a mixture of solid and liquid, and finally at this point, after reaching this point, the melting will end. After reaching to this point, the melting ends. Now the question is that what is the temperature at this point? Is it higher than this temperature?
No, same temperature.
The same temperature because it is a phase change process. Phase change process,
Yes.
your temperature will remain constant. Now after that, you have to, if you further heat it, the temperature will again increase. So the temperature, it is something like this. So it is something like this. Initially you start to heat this. If I try to plot a diagram between volume and temperature, initially the temperature is increasing, the volume is also increasing because solid expansion. After that there is a melting process. During melting process,
স্যার ভিটা এক্স অ্যাক্সিস বরাবর হবে।
sorry, okay. Thank you. So yeah, so if it is my temperature, if it is my volume, so if we start to heat it, the initially it is the solid heating part, then it is the melting part. After that what will happen, it will again further start to heat due to the sensible heating of the liquid phase. After that it will reach to boiling point, then it will be go again like this. So this part is the sensible solid heating, this part is the sensible solid heating, this part is the melting, and this part is liquid. Please mute yourself. And this part is basically the boiling process. So if it is at 1500 degrees Celsius, if we further heat it, so what will happen, the liquid metal temperature will start to increase. So it will become 1700, 1800, 1900. When it will reach to 2600 degrees Celsius, so what will happen, it will reach to its boiling point. So this point is the point where it just about to boil. So after that the boiling will start, and after reaching the same temperature, because we know that during the boiling process the temperature will remain constant, after reaching to this part, the liquid metal or the liquid iron completely converted into vapor, and if we further heat, it will become superheated. This part of the diagram is known to me. So just like there is a zone where it is in mixture condition of liquid and vapor, here there is a zone where it is mixture of solid and liquid. So have you understood what I have mentioned? Now if we look at the bottom, there will be a pressure. After that, if you go below to that pressure, you will find that if you start to heat a pure substance, the temperature will increase, and there is a process line after which it will start to convert into vapor. So if we carefully look at this point, before that there was, if you are heating through a constant pressure line, so there will be solid, liquid, then you will find vapor. But if you comes down to a low pressure, what will happen, the solid will directly convert it into vapor, and after that the whole solid will completely converted into vapor. So this is the end of sublimation process. So in the last day I told you there are, if I go back to that, this is the sublimation. So what is sublimation? When the solid directly converted into vapor, and this happens if you go to very low pressure. After a certain critical pressure, if you go very low, the solid is, after reaching to that pressure, the solid will directly convert into vapor, and whenever it is converting into vapor, there is a line. So along this line the conversion starts, and along this line, whenever it will reach to this line, the conversion end. So that is why, if we last day we were discussing about camphor at 1 atmosphere is basically below this pressure line. So whenever camphor absorbs heat from the environment, as it is below than this pressure on the base, which is based on the property, material property, at 1 atmosphere the camphor is less than this pressure, this critical pressure. That's why the camphor is directly converted into vapor. But this is not going to happen for water. If you have a ice, the ice is never going to convert it into vapor, because at 1 atmosphere pressure, what happens, because ice, the 1 atmosphere pressure is basically above that pressure level where 3 phases can exist. But below, after low, if you go down to a certain pressure level, you will find there will be sublimation. So there will be even a pressure where ice can convert into vapor, but that pressure is very low. But for camphor or maybe for naphthalene, the whole solid converts into vapor at atmospheric pressure itself. Any doubt up to this much? Any doubt up to this much? Do you understand? বোঝা যাচ্ছে? সবাই বুঝতে পারছে?
So in case of alloys, the different composition materials means if a gold and aluminum alloy, the different chemicals
at this point of time, please do not consider the alloy thing.
Okay.
It will further confuse you, because I told you that whenever there is an alloy and you are talking about melting process, it will not become pure substance. So you forget the concept of alloy, you simply consider a single metal.
Okay, sir.
Any other doubts? Please confirm, otherwise I can't proceed.
No, sir, there is no doubt.
Do you understand the sublimation procedure?
Yes.
Okay, so now the next
স্যার ট্রিপল লাইনটা কি বলেছিল?
আবার বলো।
ট্রিপল লাইনটা?
হ্যাঁ, ওটাই বলবো। So there will be a line at certain pressure. What will happen at that pressure? What happened that you see, just give me a minute. You see, this zone is completely solid vapor zone. This zone is liquid vapor zone. So now at this point, below to this line, solid and vapor can exist simultaneously. Above this line, liquid and vapor can exist simultaneously. It is said that along this line, the liquid the solid and the vapor, they can coexist simultaneously. They can exist simultaneously. So there it may happen. So basically it is it is telling you a condition where, suppose this is maybe a piece of, this may be just a container, and over that container you placed one solid metal. As you are heating it, the solid metal has started to melt. So some part of that metal is converted into liquid, and simultaneously some part of the liquid is getting converted into vapor, which is very unnatural. Like whenever you have a piece of ice, whenever it starts to melt, you will find water. If you heat this water, then the ice completely vaporizes, the ice completely melts, and after reaching to a certain temperature, then only you can see the boiling. But the triple line is a special line where this melting and evaporation of liquid, all these things are happening simultaneously. This diagram says that. So this line is basically called the triple line. So if I tell you the definition of triple line, so on PV or TV diagram, this triple phase states from the line is called triple line. The states on the triple line of a substance have same pressure, same temperature, but different specific volume. What did it mean by different specific volume? It is trying to say that the vapor is having a different specific volume, liquid is having a different specific volume. So there are multiple phases, they are existing at the same time. So the triple line appears on a point on a PT diagram. Why it is PT diagram? Why it is appearing like a point in the PT diagram, that I will tell later. But this whole line is called triple line. This line is called triple line. Now, if you have understood this part of this diagram, then I will go to the next part. So this diagram is valid for a metal or maybe substances that expands continuously. If we heat these substances, it expands continuously because this is the volume. So you started with solid, then the specific volume increases, it became solid plus liquid. Then you further heated, the liquid expanded, become liquid which is about to boil. Then you further heat it, it became vapor. Then you further heat it, it became superheated vapor. So during the whole process, the specific volume continuously increased. Okay, so this is the one kind of PV diagram for a specific kind of substances. These substances always expands during melting. This type of substances expands during melting. But life is not so simple. We know that if you have a piece of ice at 0 degrees Celsius, and if you have a container of water, same mass at 0 degrees Celsius, which one will have higher volume?
The
Ice.
ice.
So what happens, that ice, if you have 0 degrees Celsius ice, if you start supply heat, that ice will melt. Now during this melting, what happens? The volume contracts. But that doesn't happen for the previous cases. If you have a piece of iron, if you start to heat it, if it is melts, during melting it expanded. But if you have a piece of ice, if you start to melt it, the end volume will be lesser after the melting process. So this is a anomalous behavior that already you have studied in your school. Okay. So now, how this PV diagram will look for those kind of substances, and which is very normal, common to us. This behavior must be anomalous, but water is very common to us. So we need to understand the phase change diagram of water. So what is happening? Again, consider one constant pressure line like this. This is the constant pressure line. Consider that this is at 1 atmosphere. Very good. So this is 1 atmosphere. So this line is solid. So if I consider one pressure, so if you are somewhere there, so if we start to heat it, what will happen? It will reach to, suppose, 0 degree Celsius ice. Okay. Now, after that, if we start to heat it, it is not at 1 atm pressure. I am just explaining the behavior, then I will mention the operating pressure. So it is not exactly 1 atm, but just consider that this is the melting point. So now, whenever the solid will reach somewhere there, it is at the melting point. The melting process will start, and after the melting, it will reach somewhere there. This is the end of melting process. Now, during this process, what happens? The volume
But sir,
expands.
volume expands here.
Yeah, that I know. Now, after reaching to 0 degree Celsius, this is 0 degree Celsius liquid. Now, if we further heat it to reach its boiling point, suppose this is the point, this is 0 degree Celsius. If you start to heat it, we know that up to 4 degrees Celsius, the volume will decrease. After reaching to 4 degrees Celsius, then it will again, the volume will increase. After a certain point, it will reach to the boiling point. Then the boiling will start. So this is the beginning of the dome. So if I explain it further, just wait another illustration. So you are somewhere there. Initially you are heating it. After that it is reaching to its melting point. Melting will start here, and finally the melting will end somewhere there. But now the anomalous behavior will start. 0 degree, 4 degrees Celsius liquid has less volume than liquid of 0 degrees Celsius. So due to this, you have to reach 100 degrees Celsius. So you will be heating from 0 degrees Celsius. So whenever 1 degree, 2 degree, 3 degree, 4 degree, what is happening? It is moving in this direction. And after reaching to a certain volume, that is at maybe minus, that is will be at 4 degrees Celsius, it will again will start to move in the rightward direction. After that, whenever it will reach to 100 degrees Celsius, maybe at this point, if it will reach at this point, then if we heat it, the boiling will start, and after a certain time the boiling will end. So this is the anomalous behavior which is happening in this zone. So this is why the water is different from other substances, and there are other substances like bismuth that also follows the similar kind of behavior.
Sir, I have a question here.
Yeah.
Sir, here when during the melting, that means when ice melts just to water, then what will be the volume change? Here, actually, according to the picture, when ice melts to water at 0 degrees centigrade, the volume increases. But
Yeah.
but volume of ice is higher than volume of water. That is, I am not understanding.
Yeah, good question. So that you need to further just verify. If you can if you will start to read the steam table, then it will be clear for you. So just wait for what I'm trying to say. First statement is the volume this is the volume where your melting process will start, and this is just wait. I think here is some typographical mistake, some kind of. I show you one more easier diagram. Yeah. Yeah. So if you look into this diagram, so this diagram is visible to you?
Yes, sir.
Yeah. So this is the point 1. Marker is there. Okay, anyway, so what I can do, I can simply take a snapshot of this and put it in our plot. Sorry for this editing time. This diagram is creating confusion. So if you look into this diagram, so this is the one initial process where you have a piece of ice at maybe minus 40 degrees Celsius. If you start to heat this ice, it will reach to 0 degrees Celsius. So this is the saturated solid line from where the melting will start. As you are rightly pointing out that during melting, the volume will contract perfectly. So it is the 0 degree Celsius ice, the volume will contract and it will reach to 0 degree Celsius water. So that is why this line is the saturated liquid line. But saturated liquid, but in terms of solidification procedure. And after reaching to this point, 0 degree Celsius ice, 0 degree Celsius water, if we further heat it, it will go up to -4. -4 is somewhere there. Then again it will take a round and reach to 100 degrees Celsius. Then the boiling will start and it will end somewhere there. So if I again repeat it, if you are not able to still follow it, I am just repeating for the last time. So this is -40 degrees Celsius ice. If you heat it, slowly the temperature will increase, and also due to heating, the ice will also expand. And after some time, if I consider this pressure as 1 atm, at 0 degrees Celsius, it will completely convert into ice. It was previously, it was also ice. Now it is a ice which is about to melt. So if it is about to melt, if we further allow it for the melting process, the volume will reduce. So it will go somewhere there. After reaching to this point at 3, it is now 0 degrees Celsius water. It is 0 degrees Celsius water. Previously it is 0 degrees Celsius ice. Here it was 0 degrees Celsius ice. Now it is 0 degrees Celsius water. If you further reduce the temperature, further increase the temperature up to 4 degree, the density will increase. This may be 4 degree. After that, again, it will start to expand. And gradually, the temperature will reach and finally heat this point. Because this is happening at same pressure level. So it will hit this point, and this is the line where the liquid is just about to boil. So boiling will start at 100 degrees Celsius and the boiling will end at 100 degrees Celsius. The complete liquid is basically converted into vapor. Any doubt up to this much? Is it clear now?
এই কেসেই তাহলে মানে হচ্ছে এখানে যে স্যাচুরেটেড যে সলিড লাইনটা তাহলে মানে এদিকে যে স্যাচুরেটেড হচ্ছে ওই লিকুইড লাইনের যে পরে হবে, তাই তো? মানে একমাত্র এই কেসটার জন্য।
হ্যাঁ হ্যাঁ হ্যাঁ, এইটা হচ্ছে স্যাচুরেটেড সলিড লাইন।
হ্যাঁ, স্যাচুরেটেড
লিকুইড লাইন। Previously you have this one is your liquid line, solid line, this one is your liquid line, this one is your saturated liquid line, and this one is your vapor line. So this is solid, this is liquid, and this is liquid which is about to vaporize. Here you will see the liquid line will come earlier. This is liquid, this is solid, and the liquid which is about to boil, it may come somewhere there, it may come somewhere there. I am explaining another fine thing. If you look at this point, can anyone explain me that what is happening above this pressure and what is happening below this pressure? Why this point is interesting, or why there is an intersection here? What is happening above this pressure and what is happening below this pressure? Anyone?
এখানে solid to gas এ directly conversion.
No, solid to gas is there.
Oh yes, solid to gas is here.
What is happening there? Anyone?
তো ভলিউমটা সেইভাবে বাড়তে পারছে না প্রেসারটা বেড়ে গেলে।
না হচ্ছে ওই প্রেসারে মানে সেম ভলিউম হবে, মানে ওই সলিড মানে আইস আর ওয়াটারের সেম ভলিউম হবে।
আইস আর ওয়াটারের ভলিউম সেম হবে। কোন আইস আর কোন ওয়াটার? যে আইসটা জাস্ট মেল্ট করতে শুরু করেছে। আর ওয়াটার মানে কোন ওয়াটারটা?
জাস্ট যেটা বয়েল করতে,
পারফেক্ট,
জাস্ট যেটা বয়েল করতে শুরু করেছে।
Perfect. So here what is happening? This is the ice. Ice is converted into liquid. Then liquid is further heated to boil. So there are three initial points. 1, 2, 3. Here what is happening? This is 1, this is 2, and again it is coming back to 3. So the volume at which it started to melt and the volume at which it is about to boil, they are same accidentally. So this may be some special type of pressure. Just I am trying to explaining every part of the diagram so you can appreciate this. So you think about that. This is little bit complicated. So if you can understand this point, you have understood it 100%. If you understood the previous statement, what they were mentioning, that this is the point where the volume of the liquid which is about to vaporize and the volume of the ice which is about to melt, luckily they have same volume. Okay. So do you understand, or shall I repeat it for the last time? Should I repeat? Shall I repeat? Am I audible still now?
Yes sir.
বোঝা যাচ্ছে না আজকে নাকি? হ্যালো, শোনা যাচ্ছে?
হ্যাঁ স্যার শোনা যাচ্ছে।
Yes sir.
একটু কি হেভি হয়ে যাচ্ছে? Is it getting difficult? Are you losing interest any point of time?
নো স্যার ঠিকই আছে।
Yeah, Shushmit write out a point. He said that specific volume is difficult for us to understand, hopefully. So basically, he is trying to say that the density will be easier to give an example. So for the last time, I am giving this explanation using example giving using density. So this is ice. This ice melts. If it melts, the density, what will happen to density? The density will increase.
Increase.
Okay. After that, it is now liquid. If we heat it,
4
the
degrees Celsius.
4 degrees Celsius, up to 4 degrees Celsius, the density will increase. So it will go in the leftward direction because it is volume.
Volume
And
decrease.
volume equal to volume, the specific volume is equal to 1 by rho, 1 by density. Okay. So up to 4 degree, it will go in this direction. Then again take a turn and come back and reach there. This is 100 degrees Celsius. Now every time I'm saying it 0 degree, 4 degree, 100 degree, these are all based on one atmosphere. The whole, those numbers can change whenever you reach to this pressure or maybe this to pressure. So as we have a proper feeling that what do you mean by 0 degree and what do we mean by 100 degree, that's why I'm repeatedly using this example. 0 degree, 100 degree, 0 degree, 100 degree, because whenever I say 100 degree, it means I'm talking about the boiling process. But this temperature can change whenever you are changing your pressure. So this is the diagram. Hopefully now you understood. So
স্যার যখন সলিড লিকুইড লাইন থেকে ওই বয়েলিং লাইনে টার্নটা নিচ্ছি তখন তো স্যার আপনি নিচে নামছেন, তো প্রেসারটা কি চেঞ্জ হচ্ছে না? মানে যদি প্রেসার কনস্ট্যান্ট থাকলে তো একই পয়েন্ট দিয়ে যাওয়ার কথা।
আমি নিচে নামছি না, আমি আসলে জায়গা পাচ্ছি না বলে দেখাচ্ছি। অ্যাকচুয়ালি ইট শুড বি লাইক দিস। পারফেক্ট কোয়েশ্চেন। Once I repeated already, because it is not like we are moving like this. It is not like this. It is actually this again coming back like this. Yeah, rightly pointed out. So it is not coming down, but to show you, I am just coming down so that you can distinguish these two lines. Okay. So now triple line. So if I try to plot PT diagram, pressure versus temperature, pressure versus temperature. Up to a certain pressure, the solid directly converts into vapor. This line is called the sublimation line. After a certain pressure, you just ignore the dotted line. At this point of time, please ignore the dotted line. After a certain pressure, there will be a solid phase. This zone is solid, this zone is liquid, and this zone is vapor. Okay. Now if you look at this point, this is that point where all three phases exist. That triple line which you have seen in this diagram, the triple line that you have shown in this diagram is converted into a point. Because you see just how you can say that during this pressure, temperature is constant. The temperature is varying, but what happens? The pressure is constant. Pressure is constant and temperature is also constant. So as pressure and temperature both are constant, this complete line is converted into a single point because it is having a specific temperature and a specific pressure. So which one was a line? So basically what I'm trying to say, every process that we have shown in your previous diagram is basically the point. So here melting starts, here itself the melting ends. Here vaporization starts and at the same point the vaporization ends, because it is a PT diagram and we know that P and T never changes during phase change process. So this thing you have to appreciate, that whenever I am locating a point, this point means the whole process in this diagram, because at this point the sublimation will start and at this point itself the sublimation will end. So if we see here, what are the further information that I can extract from there? At this line, this will represent the boiling temperature, melting temperature. So for every pressure there will be a melting temperature. For every pressure there will be a melting temperature. Similarly, for every pressure there will be a boiling temperature. For every pressure there will be a boiling temperature. The interesting thing is, the most important point, that is what it is trying to say: if we increase the pressure, your boiling point, what happens to your boiling point? If you increase pressure, what happens to your boiling point?
It increases.
Increases. So what we have done till now, we have understood this line. This line is understood to us. We have completely understood this line. But there is a point, which point is called the critical point. Above critical point, there is no vaporization. That we discussed in the previous class, that if we go above to that line, there is no vaporization procedure. So here is also happening the same thing. Up to this point, the vaporization is valid. Now let's try to understand this line. This is for the substances that contracts on fizzing. This is for the metal kind of objects like iron. What is happening? As you are increasing the pressure, what is happening to your melting point? As you are increasing your pressure,
Melting point increases.
melting point increases. So this is for the substances which contracts on freezing and expands in melting, just like the iron, what I have given the example, iron. Okay. Now let's look into this part of the diagram. If you go there, this is the substances which expands, the substances that expands on freezing, just like water kind of substances. So in that case, if we increase pressure, what happens to melting point?
Decreases.
It decreases. If we increase the pressure, the melting point decreases. So is it known to you, for water, if we increase the pressure, melting point decreases?
Yes, sir.
Can
Yes.
you tell me the name of the experiment that you have done in your school life? Anyone? Ke bolbe? Tell me the name of the experiment that first time gave you that idea.
সে নামটা তো মনে নেই। সে দুটো আইস কিউবকে যদি প্রেসার
নামটা
দেওয়া
বলতে
হয়
হবে।
তাহলে, নামটা বাংলায় জানি,
বাংলাই বলো, সায়েন্টিস্টের
পুনশ্রী
নাম
ভবন, সায়েন্টিস্টের নাম মনে নেই।
বলো, মনে করো পারবে। কে বলবে? What is the name of that experiment? Tell me, anyone? Pressing of 2 ice cubes. Yeah. But what is the name of the experiment? This was studied in my school days. After that, I never studied this experiment, but I can remember that name from my school days. Anyone can tell me? What is the name of that experiment? Who is going to tell me? Devallo, bolo.
Sir, solidification.
There was a name of some scientist. Someone's experiment. আর কেউ আছে? 43 এর মধ্যে কেউ মনে করতে পারছে না? Name of the scientist.
Faraday.
What?
Faraday.
No, not Thomson, not Faraday. Faraday is an electrical person. Maybe the syllabus changes. Hopefully, that's why you forgotten it. It's called bottomless experiment. It is called bottomless experiment. Bottomless experiment. বা বাংলায় হচ্ছে বটমূলের পরীক্ষা। Can you remember this? No.
No, sir.
Okay, maybe the syllabus changes somewhat, but this experiment is known as bottomless experiment. Bottomley is the scientist who did this experiment. One piece of one solid rod of ice, and he pressed one string, and that string is carrying some weight. So due to this weight, what is happening? This part of the ice is getting excess pressure. Due to that, the boiling point decreases. So now it can easily melt. So it melts, and whenever the pressure releases, it connects. So finally the string will go down, but still these two ice pieces will be in intact position. So this is the experiment that was called as bottomless experiment. So this is given by this diagram. So this is the this part is basically the for the solid that expands on freezing. So please remember this diagram. So but for vaporization everything is same, but for these two branches are different for based on two different types of material. Now if we superimpose this PV diagram and VT diagram, it will create PVT surfaces. The surfaces will look like this. If you look from the top direction, you will find what? Temperature and volume. If you look from the side, you will find pressure and volume. If we look from this side, you will find pressure and temperature. So these surfaces are common question in the examination. So you can create these surfaces using clay. So if you can see some videos in the YouTube that what is the interpretation of this diagram. So for that you need some animation. So if you see some animation, you will understand this diagram. So these are the things that I want to discuss today. So I like to take any questions if you have. If you have any questions, I can. So if I try to summarize what are the things I have discussed today, I have started with this. I discussed what is called, in the previous day I discussed about the vaporization process. Today I discussed extended this diagram for the solid phase. For the solid, I have considered for a metal piece. Then I have discussed for a substance that contracts on freezing. No, that contracts on melting. And after that I discussed about the triple point or triple line. This is the PT diagram, anomalous behavior in the PT diagram, and this much. So any doubt up to this much? Any question? Any question?